I'd like to welcome you to Traverse PC's April webinar on Coordinate Reference Systems, CRS Part 2. My name is John Balcom. I'm an LS, licensed here in Oregon, also work here at Traverse PC. Last month in April, we took a look at CRS Part 1, and you can go back and look at that in our recorded webinars. So you go to Blogs, Webinars, and you'll see the recorded webinar for last April, or last March. And we took a look at grid versus ground versus geodetic, and how Traverse PC coordinates all that in what we call a CRS, or a Coordinate Reference System. So if you were here, you got to see that live. If not, we asked you to come in and click here and watch that recorded webinar before we came in and tackled today's topic. Now today, we want to kind of pick up where we left off, and we want to take a look at 3 different case studies, different kinds of surveys: a local grid, a public land survey, which is a geodetic CRS, and then I want to take a look at kind of a hybrid that I think a lot of you will actually end up gravitating toward as you work inside Traverse PC. Now, I don't know how far I'm going to get today, but I think we'll probably keep this series going in May and probably do a part 3, because I know that you'll have some questions there when we get all through this. The other thing I think I'll do a little differently today is, instead of holding questions till the end, when I get done with each case, I think I'll just open it up to the chat screen, and if you have a question, you can just type that in, and I'll try and answer 2 or 3 questions before we move on. I may not get to all your questions, but let's try and tackle a couple of them after each part. So let's look at our outline here. This is what I want to cover for each one of these cases that we look at. I want us to come in and select a coordinate reference system. I want us to select the distance and direction types appropriate for what we're going to do. And then let's take a look at the distance, direction, and areas that we end up using for each. Let's take a look at what Cobo looks like, what the different reports look like. For some of these, we'll talk about the deliverables, whether that's GIS or CAD or LandXML or an ASCII file. We'll take a look at what would I do if I wanted to stake this out with a total station. What would I do if I wanted to stake this out with GPS or GNSS? And then this is kind of the fun part of it. We'll just take a look at how site calibrations kind of work for these, and when and how to use those. So for each one of these cases, we'll come in and take a look at these in some detail, and feel free to write down any questions you have, and that can be part of our discussion. Okay, let me look at my notes, then we'll jump in on case 1. So let's take a look at case 1. Working entirely in planar data, typical of boundary surveys, site surveys, topo surveys, that sort of thing. And last week we took a look at some of these diagrams, and we started out with discussion of grid versus ground versus geodetic, and then I brought up the one that was for local coordinates. And I said, a lot of times we do surveys that are just at what we call a local grid or a local site or ground coordinates. And in fact, in this particular drawing, I could just come into that CRS layer and turn that off. And now we see that even though we've still got an ellipsoid and a potential state plane grid under there, we're really not concerned about that, or we're really not considering that. We're really just saying, I'm going to do everything on a local site. And you guys know, these are the projects where you start with 5,000, 5,000, or 10,000, 10,000, and just start entering data. This is a Cartesian coordinate, so it's just sine and cosine computations. The great thing is that the coordinates directly match the measurements. So if I'm out there with a total station measuring distance on the ground, the distance I measure between the 2 points will exactly equal the inverse of the coordinates between those 2 points. So real simple. We've done this forever. A lot of times the benefit of being able to work with these readily is that I've got 10, 20, 30 years of these surveys, before we ever got into GPS type stuff. So I need to go back and work with these, bring these forward for the related surveys, and Traverse PC has all those tools to do that. So let's jump in and start a survey with this real quick and set it up the way we want. So I'm going to run another copy of Traverse PC, and let's start a new survey. Let's tell Traverse PC that we want to call this local grid. Let's come in and choose OK. Traverse PC will set itself up. Go ahead and create that. And then I would come in and start a new Traverse. And I would say maybe this is a deed. And I'm going to use something like a deed format. And maybe I'll do a boundary or a control. And let's start. And here's where I would come in and say, okay, let's come in at 5,000. 5,000. And we'll just come around and enter bearing and distance. And if we plot that, we've gotten started on something and away we go. Okay, let's take a look at some of the pieces here that we're interested in. And let me go ahead and bring up that drawing view so you can just kind of see that in the background there. So we started our survey and we didn't pay any attention to the coordinate reference system. We looked at this quite a bit in March. Remember we said we could come in and we could say, you know, really I'm not using anything here. So I'm just going to create what's called a local. And a local says I'm not doing any transformations between geodetic and a projection. I'm not even considering it. I'm not even aware of geodetics. So this is that example we showed earlier where I came in and just turned off those and the projected grid, and all we're left with is this local grid up here. Okay. The other thing we talked about last month was that we came in and looked at these project factors, and we said I don't even need to be concerned about a mapping angle or a combined factor. I really don't need even to know what my project location or elevation is, because none of that is going to affect the computations. I'm simply going to come in and say I want to use grid distance, so this is grid or local Cartesian coordinates, and I want to use a grid bearing, again grid or local Cartesian coordinates, and I'm assuming that grid bearing is due north. So really very, very simple setup in here, and I can start working with my data. I want to go ahead and just open up a survey I used in one of the previous webinars, which is just a local site survey. It's a topo, and I went ahead and used that in one of the webinars. So if you drop back to, I think it's June. Okay, June of 2018, we talked about surfaces, and we went through surfaces with this survey. So you can go watch this webinar and get the whole 9 yards on it. But I want to talk about it today in terms of the fact that it's a local site survey and kind of see what that really means. Okay, so let's take a look at what we did just a moment ago. I went into survey information and chose coordinate reference system. Okay, I don't have to have sort of my default here, and Traverse PC uses sticky logic. So as I work and create new surveys, it kind of remembers that I generally work in NAD 83 Oregon South. So if I want to do a local site, I do just like I did on the other one. I just come in and say I want a local CRS, and away I go. In the project factors, I'm just doing grid bearing, grid distance. So by the way, I could leave this in state plane, and as long as I'm not entering any geodetic positions, there's nothing to transform. So there's no work to be done, and it really doesn't care whether I've got this set at NAD 83, Oregon South, or local. This is what's really critical, is that I'm just working with grid bearing, grid distance. and I've set my survey up that way. Now the reason I set it up that way is that that's really what I've got to work with. So the client called and said, we want to get some topo done on this lot because we're going to come in and build it. So I bring up a tax lot map and take a look at what they're talking about, the tax lot. Here's the visual index from the county, so I can come in and pull the surveys that have been done. And in fact, all the pins had been set on this already. And then I went out and kind of did the stuff I normally do for everything. Brought up a last deed of record from a title company. Let me just show you that real quick. So here's the last deed of record for that property. And I'm really primarily interested in the legal description for it because I want to make sure that I'm where I'm supposed to be, but also want to do just a little due diligence to make sure there aren't any easement issues or access issues, any survey issues as I move forward on this project. And what's kind of nice is that this deed is also what I'm going to enter for the project to kind of give me my boundary. So let's drop into this survey real quick and into the traverses. So here's the deed for tax lot 2201, and I just sat down with this legal description and read it while I was typing on the keypad to get that entered into a traverse. And as soon as I had it entered, this is the lot that I had. I had some side shots for some corner ties and some of the pins that were set out there by Wolford. But this allows me to come in and say, okay, I've got a boundary that fits, makes sense, it closes. I'm kind of doing all that due diligence as I get this put in. And I'm doing all of that in local grid. So if we take a look at my coordinates here, I'm starting with 5,000, 5,000, and I'm basically just entering bearing and distance as I go. Now, I want to just point this out real quick. I'm always kind of looking for errors. So when I entered this, I entered it starting at point 1, and I created a new point 8, which I identified was the same as 1, but this allows me to compute a closing point so I can check the closure on it. So as soon as I get that entered, I'm going to hit my closure view, come in and make sure that this thing closes flat, okay, which it does. So I can come down and look at my closing points, my error summary. I think I need to make this a closed loop. Just make sure, okay, yeah, closed loop. And if I have any error in here, it'll tell me, but basically I'm closing flat on this, so I'm happy with it. Okay, let me look at my notes here, and let's talk about the fact that because I had existing monuments, there's really no additional survey work to do. So once I've got this parcel entered, I now have everything I need to orient me for the job. In fact, there's really nothing else I need to do. I'm going to go out and figure out that, you know, that tax lot map was an old plat to Florence. It never got built that way. I can go out on site and start picking up the pavement features and the topo out there. I generally am picking up all the utilities as well, kind of doing a site topo all at the same time out there. And now I'm ready to start working with this. And let's come back to our outline and let's just walk through some of these pieces, okay? So we've set up our CRS, we've selected our distance type. Let's take a look at distances, direction, and area. So this traverse got set up the same way that the survey did. So I came in to format this traverse, and it's using ground distance and grid bearing, okay? This could just as easily be grid distance and grid bearing. It wouldn't make any difference in how it computes any of this because I don't have any elevation and I don't have a projection. So in this particular case, grid distance and ground distance are exactly the same. So when I come back to the traverse, I see that these are my grid bearings and these are my ground distance. And these are the same distances I would measure on the ground based on the coordinates that are here. So that's that whole local site thing. Now if I come into the closure view, and you saw me do this just a moment ago, I've got a traverse summary that's giving me my area, both in acres and square feet. Okay? So these are not a projected area on some projected grid, they're actual area on the ground. So I don't have to do any corrections with any of this. I'm getting exactly what I want for all the distances and all the areas that are reported on this. Now let's take a look at Cobo and the reports. So if I want to come in and do an inverse between a couple of points here, Traverse PC is going to say, okay, between 1 and 2, I've got a grid distance of 4964, which exactly matches the grid distance here. Now I've got options in here to show different types of distances, but there is no different type of distance in this particular case. I could pick a ground distance and I'd get 49.64 because ground and grid are exactly the same here. But it kind of gives you a little peace of mind that that's really what I'm working with. If I ask Traverse PC to give me a summary on this, all the summaries involving a Cobo like this will tell me this is grid bearing, grid distance in feet. So if I'm going to get an area in here, it's going to be an area based on grid distance. Okay, and we just say grid or local Cartesian coordinates. So I know that's my local site information. So Cobo is real easy to track through. If I tell Traverse PC I want to do a report on this. Okay, let's take a look at the reports here just real quick. And I'm going to go into this traverse and tell it I want to do a traverse report on the selected traverse. And Traverse PC generates the report, and I can see here's my grid bearing, grid distance, all the points in that traverse at 5,000, 5,000. And so my areas, in this particular case, are ground or local square feet in acres. Any closure information is also local ground distances and bearings. What if I want to generate a legal description? So here's my legal description report. I can pick a template or whatever I want with that. And then let's take a look at these settings here. So distances, it tells me, are grid distances, and directions are grid bearings. Okay, so I know I'm working with Cartesian or local grid, and if I want to just preview that real quick, I can see that all of the distances generated in the legal description are ground or local. Same way with the bearings are all grid bearings. And again, it tells me that at the top of the legal description, so I always know what I'm working with inside of Traverse PC. Okay, let's come back to our outline. Let's talk about deliverables and kind of what that looks like. So with this particular project, and really with any project I do inside of Traverse PC, I create a deliverables folder. So let's just bring that over so you can see that. Here's the deliverables that went out for this. So there was a DWG file for the architect. Now the DWG does have coordinates, but they are going to be those local or site coordinates. So let's take a look at zoom extents on this. So here's my survey. Let's go ahead and zoom in on this a little bit and then just take a look at, here's that surface. So this is what the architect wants, polyface mesh in addition to the contours. And then he's got the information underneath it so we can kind of see how it fits with the lot and model space. And look at my coordinates. These are all regular, 5,000, 5,000, just like I expect here. ASCII points. Let's take a look at this real quick. So if I open this up, see if I've got it open with here. I'm just going to get my 5,000, 5,000, all the rest of my points here. And I always send this to the architect as well, so he's got descriptions in here and coordinate locations for everything. But I could also, send these coordinates out to a total station and do any stakeout work. Okay, so no scaling or grid to ground involved with this. I just get to work with these coordinates directly. And I think I probably had a PDF with a raster image behind it as well. It just presents a little bit better to the client, so they kind of have an idea of what I did out there. Okay, let's come back and take a look at our outline. So exporting data for stakeout, if I come back to this survey, I go to File, Export, and this is how I created that ASCII file. I can send whatever traverses I want, if there are certain things I want to stake out, and then I just send it out to an ASCII file. And I stake it out as YXZ or XYZ, whatever, with some extension that I can read into my data collector, and away I go. So pretty simple, just write that and I'm good. Now I'm really not going to be thinking in terms of sending anything to Google Earth because I've got local 5,000 coordinates. I'm not generally going to think in terms of writing anything to GIS, again, because I'm not tying into any physical world location. I've just got this local coordinate system. So great for exporting ASCII points, great for exporting a drawing to CAD, great for writing PDFs, but I'm really not thinking about communicating with the rest of the world with it. Okay, so there's really no site calibration involved in this one either at this point. So I've done everything local. I'm going to keep this one local, and I'm good to go. Save the file, send the bill off to the client, and on to the next project. Let's come back to our outline here. And before we jump into case 2, I think I'd like to change things up just a little bit and say that the case we just looked at, let's call that case 1A. And I want to take a look at a case 1B, which I think is just so typical of what we're going to run into as we start thinking in terms of GPS or GNSS, and combining that with local surveys. And you saw me do just a little bit of this with Google Earth in the webinar last month in March. But we get a lot of questions about this, and a lot of people use this. So I just want to walk through something here with you real quick. Let's turn the ellipsoid and the grid projection back on down here. And then I want to start a copy of Traverse PC and take a look at a survey from a new Traverse PC user, called in kind of walking through this process I'm going to show you. And I just asked if I could go ahead and show this or use this for our webinar today. And let's go ahead and do this same local grid, but let's use GPS with it and kind of see what that looks like. So here is a local grid survey. We started out with record data, and this is going to look real familiar to you. Here's our 5,000, 5,000, so that's what the coordinate system is here. And we entered this right of way here for a section line offset here. And basically I've got the same survey that we just worked with on that topo. But what we want to do with this one now is we want to start talking in terms of what I've just been calling a hybrid system, where we mix different data together and use the site calibration to kind of bring it all together for us. Let's just expand this out a little bit, and let's talk about what we want to do. So we want to use GPS or GNSS out in the field. How do we do that? Well, the first thing we have to do is go into the survey information, and in our coordinate reference system we have to tell it where we are. So we're going to pick NED 83, the 2011 epoch. We're in California 2, so California 2 zone, that's where this user was. And then we're going to go into the project factors, and we're going to leave this grid bearing and grid distance. Do you remember in the March discussion when we came in and looked at the different options in here? We said we've got this one called hybrid. I just want to look at the drawings. And we're really thinking in terms of I can work with a state plane, a grid, and I can bring it up here. Okay, so maybe I shouldn't be calling this one hybrid, because really I'm still just working with local. Okay, but I'm going to be using the ellipse and the projection just like I did in that hybrid that we talked about, even though I'm at 5,000, 5,000, not state plane. So I'm going to be working in grid, bearing, and distance. I'm going to be working on a state plane grid. So now I have a way to compute geodetic to projection coordinates, or in this case state plane coordinates. So this user went out and imported GPS data. So they went File, Import. In the ASCII settings, they said I'm going to bring in point, latitude, longitude, and description with a CSV extension. We're going to generate details for that so we can see what it did and add those points to a traverse. Here's the file we brought in, and if we just preview that real quick, it'll open up Excel because it's a CSV, and on my computer that's the default program to open that. Let me just make sure this is big enough here. But can you see that point 11 has got a latitude, a longitude, and a description. So whether this was RTK or post-process, it really wouldn't matter. Out of that GPS or GNSS system, we just exported the geodetic positions that we collected in the field. Now, this is important. I can do this in the field, or I can come back and do this in the office. Point 16, which is a geodetic point, we said is the same as point 1 in our local survey. And we used a #1 space to identify that. We did the same with 17, which equals our point 3. We did the same with 4, and we did the same with 2. So we've got 4 points here that either in the field or back in the office, we've identified this GPS point is the same as that local point. And I'm going to show you why we did that here in just a moment. So we go ahead and import this into our survey. And here's what I got when I imported that just a little bit ago. I converted my decimal degrees to degrees, minutes, and seconds. Here are my descriptions that came in with those same pound here. And now if I open up this traverse that it created, I'm going to see, and let me go ahead and just turn something off here real quick. I'm going to see that here are my state plane coordinates generated from those geodetic positions based on my coordinate reference system. Now, if I were to plot these up, they're going to be plotted up in state plane coordinates. So my coordinates in this drawing are going to be, millions and millions in the x and y, because that's what the state plane coordinate projection produces at this geodetic location. And then, of course, here are my geodetic points. Now, I'm going to use this formatting in here to identify what I'm really working with. And I've told it that I want geodetic points to be this royal blue and italics. So that's why it's drawing them that way. You're going to see in a minute, I've told it calibrated points, I want those underlined with normal fonts. So just a way to kind of identify what's in here. Now, of course, you know that if I were to go ahead and plot this, I would end up with a dot at 5,000, 5,000, and I'd end up with a dot at the state plane positions. But watch what we're going to do. I'm going to go ahead and tag this just so you see this as soon as we are ready to roll on it. We're going to come in and create a calibration to go ahead and reconcile those GPS or GNSS positions with our local survey. So right now, before I calibrate, I've got geodetic positions, I've got state plane coordinates, and I've got local coordinates all in the same survey. And the problem is they just don't match. So I'm going to create a calibration then, and we're going to reduce that to geodetic positions and local grid coordinates. And the way I generate this calibration is really easy. I just say, I've already got a traverse where I've used some character, in this case a pound, but you could use whatever character you want. I've used some character in the description to relate the points. So I'm going to select that traverse, Southline CSV, and I'm going to tell Traverse PC, go ahead and generate a calibration for that. And let's just look at the information we got here. So here's my rotation, and I'm doing a 2D conformal, so that means the relationship between points X and Y hasn't changed. If there was some distance between those points to begin with, that's gotten factored, but so have all the other distances. So if one distance is twice a distance, after the calibration, it's still going to be twice the distance. So that's what conformal does for us. And I'm looking here seeing I've got very little scaling, I've got just a slight rotation, so it's kind of what I expected. And then I've got this large translation. And I can come in and look at the points, and here's that point again that identifies that 14 is the same as my local 2. So here's my 14 state plane position. It's the same as 2, which is my local position. And of course I've got this huge translation difference between it. And I've got 4 point pairs like that that I'm using to generate the calibration. And then I've got these uncalibrated points that are also going to be calibrated based on whatever calibration I generate here. And then I'm just going to come in and tell it, okay, let's save it as Southline CSV. I'm going to tell it, here's the survey that generated that calibration. This is just some record keeping for me, so I've got some notes. I'm going to tell it I'm going from NAD 83 California GRS 80, and I'm going to go to a local site. And this is just some reference for me that kind of helps me keep track of what I'm doing here. I've saved this earlier, so I'll go ahead and overwrite that. So I've now created a calibration file that relates those GPS points to my local survey. And all I have to do is go into my Site Calibration tab for the survey and say, apply this calibration, and I can reload it here and say this is the one I want to use, it's the one I just created. Apply that to geodetic points. And as soon as I do, here's my GPS points, no longer plotted at state plane coordinates, instead plotted at my local site. And in fact, you can see I'm lining up with my record points in those GPS points at all these corners. Exactly what I want. So now my features are in the right place, my boundary is picked up properly, and I've now reduced this survey to geodetic positions and local site coordinates. Let's take a look then at what happened to this traverse. Now, we had this open just a moment ago, and we can see that, remember I formatted these to underline anything that's been calibrated. So all these points now have been calibrated, and instead of seeing the state plane coordinates, I'm seeing the local site coordinates. In fact, if I went into any one of these points, and I'll use one that got calibrated, and we say modify points, point properties, I'm seeing the coordinates for that point, and these are the calibrated. I could also say, show me the uncalibrated. Here's the state plane positions. Okay, but I'm using this Southline CSV calibration. There we go. And here are the calibrated positions. So these are my local site coordinates for that point. So now let's talk about some workflows. I've got this set up the way I want, and let's talk about what I might want to do next with this. So let's say I'm going out tomorrow and I'm collecting more site data. I kind of got this much done while I was out there today, and I wanted to make sure I came back and everything matches up. Now I'm going to go out and gather more data. What do? Well, I go out and get the data. Tomorrow I come back and I import, just like I did. I import ASCII. I bring in the same information in a CSV file. Traverse PC imports it. It adds another traverse to my traverse manager, and sometimes I'll come in and put the dates on these so I know what date I brought those in. or go in and make some notes in the properties and say, you know, this is my preliminary stuff. I went out today and picked up some septic drain fields, or you know, whatever I was picking up that day, and make some notes about that. But now these points are going to be plotted where they belong over the local survey, or local site survey, because of the site calibration. So all geodetic positions, regardless of whether I collected them yesterday or today or a week from now, are all going to be calibrated to local site automatically. So it's like I never have to think about that again. It just kind of happens for me. So when I was working with the user on this particular survey, they said, well, now I'd like to see this in Google Earth. How do I do that? Well, it's simple. Google Earth needs to have some way of getting me from whatever coordinate system I'm in to geodetic positions. So basically, Traverse PC is going to say, take these coordinate positions, reverse the calibration, so it's going to go from local to state plane, and then the coordinate reference system is going to take those state plane coordinates and transform them into latitude and longitude. And that all happens automatically when I say export this. Let's export this entire survey as a KMZ. Let's go ahead and make sure that the line data is visible. I don't have any surface stuff I need to do, so that looks good. And we're going to go ahead and just write that. It's already in there. Let's overwrite it. Close that. Now let's go out to Google Earth and bring this into Google Earth. And I'm going to say File, Open. I'm going to navigate to that folder, okay, and I'm going to bring in that Google Earth from Traverse PC. Here it is. So I've got those points that I collected. Okay, and I've come over and picked up some additional centerline stuff over here. I've got my boundary. I've got some site work in here. Pretty cool. I can come in and turn on, send over different types of information with Traverse PC. But I just wanted you to kind of see that here are all the GPS points that I collected. I wanted you to see what those would look like here. So now, even though my survey is in local coordinates, 5,000, 5,000, the site calibration allows me to work with that survey inside Google Earth. So I've got all my survey boundary work here. Whatever traverses I had generated at that local site would also show up here because I sent over the entire survey. So great, now I can work with my survey inside of Google Earth. So what if I want to work with this inside of my survey? Let's go ahead and just kind of get this set up about where I want it here. And I'm going to go ahead and just snip a little bit of this. And I'm going to leave my Traverse PC points and stuff in there. I think it'll just make it a little easier for you to kind of see how I'm going to do the calibration of the photo here in just a minute. And let's go ahead and save that. And I'm going to call it Google Earth Background. And we'll just write over the top of what we had earlier. Okay, so let's leave Google Earth for now. Let's come back to our survey. And let's show you how this works. So I'm going to insert a photo. So I can do that out of the Insert menu, bring a picture in, or I like to use a little toolbar here. I'm going to pick that photo, and I'm going to say, go ahead and bring that in for me. Now, originally, I didn't have any world file created for this. In fact, I could go into the photo, and I could say, you know, remove that world file I had created earlier. So I just brought the photo in kind of close to where I knew it would be. And now I want to come in and calibrate this so I get it spot on. And I want to show you how that works. Let's go ahead and just zoom in on one of these corners over here so you can see how we're going to do this. I'm going to right click this photo and calibrate it. And I'm going to not use an existing calibration. I'm going to create one just for the photo. And I've got two options as far as point pairs or series of points. And I can also save this calibration, but I'm not going to. Usually calibrating a photo, it's pretty rough because if I don't have survey markers in the photo, and in this case I don't. I have like survey points I sent over, so I'm going to be accurate because of that. But most of the time I'm just kind of picking features off the photo, and it's not that exact, so I don't tend to save those. But I'm going to tell it I want to do point pairs, and I hit OK. And now I just follow the prompts. I pick the uncalibrated first, so I'm going to get about the location there. And then when I go to pick the survey point pair, I'm either going to do an end of line or an insert. I'm going to do insert. If I pick the label, it'll snap to the point itself. Okay, and that's what it did. And you can see here's my line between the photo point and my survey point. And let's just go around and do that for all of these. I'm going to pick point 2, and I want to calibrate that to 14. And I could go to the GPS or my record point, either one, because they're the same now, basically. Here's my 16. And I'm going to go to the insert of this one. Here's my 18. And I'm choosing, oh, I think I got the wrong one back there. Let's go down and just check. No, I got the right one. I wanted the out type, most easterly for the boundary, not the right-of-way one. So now I'm going to pick my 18 here and snap to 18. Okay. Right-click to tell it I'm done. Traverse PC gives me my report for the calibration. So even though I'm not saving it, it still lets me come in and see what it actually computed here. So I know what I did for scaling and rotation and offset. And of course, here are the points that it moved. And now I've got a photo calibrated to my survey. So easy enough for me to send my survey to Google Earth and work inside of Google Earth, or to grab a photo, in this case out of Google Earth, and bring that into my survey and calibrate it so now I can work on top of a background photo. And generally what I do inside of Traverse PC is that I like to put those photos on a background layer. So every drawing in Traverse PC has a background layer. I'm just going to move it to that layer, and now I can turn that layer on or off. So I can come into layers and I can say I want the background layer on, see my photo, turn the background layer off, I don't see my photo. Just kind of a nice way to be able to work with that readily. Okay, let's come back and take a look at our notes here then. Okay, let's just talk about in this hybrid system, Cobo reports deliverables. It's not too hard. It's exactly the same as that local site. So all of my survey here now is really local coordinates, 5,000, 5,000. So I can export ASCII points to an engineer or an architect. I can write a DWG of this, or a DGN file, a CAD file of this, and send it off to the engineers, architects, the city. And everyone's just working at 5,000, 5,000. And as long as we're all good with that, there's really nothing else for me to do because the coordinates are at the ground, and any inverse between those coordinates will exactly match the ground distances. My grid bearings are due north, and everyone's happy as a clam. So just like that site topo survey that I did with the total station, we've now done a site survey with GNSS. And because we've calibrated it to our local site, we can reverse calibrate back to geodetics. So now I really could think in terms of, you know, I could export this, and there's no reason I couldn't write an Esri shapefile and send this out to GIS. Okay, because I can write this out as a geographic, and I could now reverse calibrate from local to state plane, transform from state plane to geodetic, just like I did for the export to Google Earth. But now I would export to a geographic shapefile, and that shapefile would include the latitude and longitudes that the Google Earth file had. So it kind of opens up doors for me now to really think in terms of working locally with a local site, or if I needed to, going out to geographic or geodetic locations for Google Earth or GIS. Kind of some neat opportunities I get when I start mixing or using this hybrid kind of system with Traverse PC. And of course, I'm just kind of reworking the workflows that this Traverse PC user was asking about. But you can kind of dream up, well, what do I do with this? You know, what are the things that I end up typically doing? And come up with your own workflows. And they're this simple. I mean, I'm doing more talking than I am clicking here, but you can see how quickly I can get this information out to Google Earth, get the photos in and calibrate it and work with them here now. And I think you'll find your workflows are kind of fun like this and pretty straightforward like this as well.